Hello friend, welcome to the abstract algebra class. It is class 66. In this class we want to define product of permutation, and also we will solve an example. First, here is the product of permutation to permutation, how we can multiply to permutation. Let f equal to a1, a2 and so on, an, b1, b2 and so on, bn, and g equal to b1, b2 and so on, bn, and c1, c2 and so on, cn. b2 permutation defined over same CTS. Both are defined as CTS. Here b1, b2, bn, comma c1, c2 and cn, nothing but the elements a1, a2, and so on, an of s in same order. That is, f of a1 is equal to b1, f of a1 is equal to b1, f of a2 is equal to b2, f of an is equal to bn, and so on. Similarly, g of b1 is equal to c1, g of b2 is equal to c2, and so on, g of bn is equal to cn. If we multiply these two, we can write g of f of a1 is equal to c1. If we multiply, also g of f of a2 is equal to c2. Here f of a1 is b1. If we put b1, we have, it is g, it is not b, f. It is g of b1, g of b2, g of bn. G of b1 is equal to c1. Therefore, g of f of a1 is equal to c1. G of f of a2 is equal to c2, and so on. That is, it means g into f of a1 is equal to c1, g into f of a2 is equal to c2, and so on. G into f of an is equal to cn. The product of g into f we can write as, instead a1 c1, a1 g into f of a1 is equal to c1, g of a2 is equal to c2, and so on. G into f of a1 an is equal to cn. Actually, the product of these two permutation which is given in here is equal to these things. Note g into f is equal to, instead g we can write b1 here, b1 c1, b2 c2, and so on, bn cn. Instead of f we can write a1 c1, a2 c2, and so on, an cn. If we multiply these two, here is a1. They are b1, not c1. These elements are b1, b2, and so on, bn. Here we have a1, and under a1 is b1. Actually, the image of a1 is b1. Here is the here b1 is pre-image, and image of b1 is c1. Therefore, actually, we got it as a1 into b1 into c1. We take a1 into c1, a2 c2, and so is the definition of two permutation. Here, example, if a is equal to 1 2 3 and 2 3 1, b is equal to 1 3 2 1 3 2, find a into b, comma b into a. First, we want to find a1. a1 is equal to 2, a2 is equal to 3, a3 is equal to 1. Here b1 is equal to 3, b2 is equal to 1, b3 is equal to 2. we have these values. Now we want to find A into B1 is equal to A into B1 is equal to A instead B of 1 is equal to 3 is equal to A3 we have 1. A B of 2 is equal to A B of 2 is equal to A of instead B of 2 we can put 1. A of 1 is equal to 2. A into B of 3 is equal to A into B of 3 is equal to A B of 3 we have in B of 3 B of A of 2. A of 2 is equal to 3. Actually A into B is equal to 1 2 2 3 3. It is nothing but identity permutation. It is identity permutation. We now want to get B into A. B into A of 1 is equal to B of A of 1 is equal to B of instead A of 1 is equal to B of 2 is equal to 1. B into A into B into A of 2 is equal to B of A of 2 is equal to B of A of 2 is equal to 3 is equal to B of 3 is equal to 2. B into A of 3 is equal to B of A 3 is equal to A of 3 is equal to B of A3 we have 1. B of 1 is equal to 3. This implies B into A is equal to B into A is equal to 1 1 2 2 3 3. It is also identity permutation. It is also identity permutation. Actually, we find A1 and A into B and B into A. We find all of them. Methods as A into B is equal to instead A we can put 1 2 2 3 3 1 into instead B 1 2 3 3 1 2. It is equal. Here we have it is first set, it is second set. Now first set from right side we take 1 we write first row 1 2 3 1 under 1 is 3 under 3 is 1. Here is 2 under 2 is 1 under 1 is 2. Here is 3 under 3 is 2 under 2 is 3. It is the value of A into B. B into A we can write instead B we write its element, its value 1 2 3 3 1 2 into instead A we put 1 2 3 2 3 1. It is equal to now same as A into B we can also find it is here A is first set, it is second set, first set Here we have 1, 1, 2, 3. Under 1 is we have 2. Under 2. Under 2 here we have 1. Here is the image of 2 is 3. The image of 3 is 2. Here the image of 3 is 1. The image of 1 is 3. Thank you.